In this class we are going to see principles of compiler design. So in this class, compiler design introductions. So introduction to language processes, structure and phases of a compiler, compiler construction tools. Programming languages. So programming languages are used to describe the computations. It acts as a bridge between human and machines. So all software written using programming languages. A program must be translated into machine level language before execution. Then what is a compiler? Compiler translates source program into target program. It also reports syntax and semantic errors in the source programming language during the compilation process. It produces executable machine code or assembly level code as an output. It is one of the system software component. This one gives the compiler model. So compiler takes source program as an input and produces target program. So input can be given to target program, then output is generated from the target program. Then interpreter. The interpreter executes source program line by line. It does not produce a separate target program, but the execution is very slow compared to compiler. But it produces better error diagnostics than the compiler. So interpreter takes source program and input as parallel and produces the output. The difference between compiler and interpreter: compiler performs faster execution, it produces separate target program, but interpreter executes very slowly and executes directly. Compiler errors are shown after the compilation process only, but interpreter shows the errors during the execution of the program itself. So there are another processes, that is hybrid language processes. Java used this hybrid language processes. So Java compiler perform both compilation and interpretation in a single phase. The source code is compiled into bytecode. This bytecode is executed by Java virtual machine. So this Java virtual machine supports platform independence, so it can be executed in any platform. So the translator takes source program as input and generates bytecode. This bytecode is an input to the virtual machine. The virtual machine runs the bytecode and produces the output. This one gives the language processing system. So the first language processing component is preprocessor. The preprocessor combines all the modules of the source program into a single file. So this one gives a modified source program. This will be given to compiler. Compiler converts this modified source program into target assembly program. This target assembly program is given to assembler. The assembler converts the assembly language program into relocatable machine code. Then this relocatable machine code is given to loader or linker. This linker or loader performs combining all relocatable object files into the machine code, and it also adds library files to the machine code. After that it produces the target machine code. So the preprocessor performs macro expansion also. Compiler performs source to assembly level code. Assembler converts the assembly level code to machine code. Loader and linker performs creates final executable target program. Then structure of a compiler. There are two major components. One is analysis phase, another one is synthesis phase. So the analysis phase is known as the front end of the compiler. Synthesis phase known as the back end of the compiler. So these two phases use a simple table throughout the compilation process. There are several different phases are available for the compiler. There are 6 phases are identified. The first phase is lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. So this diagram shows us the all phases of compiler, how the phases are connected with each other. The first phase of the compiler is lexical analysis. So the outcome of this lexical analyzer is produce the stream of tokens. So this lexical analyzer converts characters stream into tokens. So the lexical analyzer reads the source program character by character and identifies the tokens. So these valid tokens are given to the next phase, that is syntax analyzer. The lexical analysis also removes white spaces and comments available in the source program. It creates the symbol table for each and every tokens identified in the source program. Some of the example tokens are ID, number and operator. Syntax analysis, this is the second phase of the compiler. It checks grammatical structure of the source programming language. In order to check the grammatical structure, it uses context-free grammars. The output of the syntax analysis is syntax tree. So this syntax tree detects some syntax errors from the source program. Third phase of the compiler is semantic analysis. So this semantic analysis ensures the semantic correctness of the source program. It performs type checking. It also handles the type conversion. So type checking means it checks whether the operator has the two equivalent operands or not. So it also performs type conversion also if one of the operand is integer and another operand is floating point, means it automatically convert integer into float. These type of type conversion or coercion operations are handled by the semantic analyzer. It also uses the symbol table to get the information about the operands. Next phase of the compiler is the intermediate code generation. It produces machine independent intermediate representation. The intermediate representation uses 3 address code. So in this 3 address code, each instruction takes 3 operands. So it simplifies the optimization and code generation. For example, T1 equal to A star B, it is one of the intermediate code representation. Then code optimization. This phase optimizes the intermediate code generated by the intermediate code generator. So the improved optimized code increase the performance of the target code. So this optimization phase removes some redundant computations from the source programming language. It reduces the memory usage also. So the code optimization can be done in 2 ways, whether it may be a machine independent code optimization or machine dependent code optimization. The next phase of the compiler is code generation. It generates the target machine code. So while generating the target machine code, it assigns registers to the identifiers and variables. It handles storage allocation also, allocates memory locations to the variables. And finally, it produces executable output code. So all the phases refer the symbol table. So symbol table management is one of the main part in the compiler phases. This symbol table stores identifiers and attributes of the identifiers. So that attributes such as type, scope, storage locations are stored in the symbol table. So this symbol table is used by all phases of the compiler. So in order to use the symbol table, efficient lookup operations are required. So this diagram shows us all the phases of the compiler. Let us take the one example statement, position is equal to initial plus rate into 60. This is one programming language statement. How this programming language statement is compiled into different phases of the compiler. This statement is initially given to the lexical analyzer. The lexical analyzer converts this programming statement into sequence of tokens. Here the first one, position, is identified as a token. So this token is entered into the symbol table position. So this position takes the token ID as ID 1. So this 1 represents symbol table entry. So in the symbol table, first position stores position token. So ID is the name of the token for the position, 1 is the symbol table entry. Next token is equal. So this is represented for the equal token. Then initial is converted to second ID. So ID is the name of the initial token. then 2 is the number of simple table entry, plus next token is plus, next rate is converted into id comma 3 is the symbol table entry. In the symbol table, third position rate is entered, then star is the token, then 60 is the constant value. So the output of the lexical analyzer is the sequence of tokens. This sequence of token is given to the syntax analyzer. It generates the syntax tree like this. So there is in syntax tree, the middle internal node is the operator, the leaf nodes are child or identifiers. So this syntax tree is given to semantic analyzer. The semantic analyzer performs a type checking and a type conversion also. Here 60 letters 60 is in integer. Suppose I in position the initial rate or in floating point number, means 60 should be converted to float. Let us assume id, that is position initial rate are in floating point values. So 60 is converted into float. So this type conversion is performed in semantic analyzer phase. So this modified syntax tree is given to intermediate code generator. This intermediate code generator generates 3 address code, sequence of 3 address code. So the first T1 instruction performs this into to float operation. 60 is converted into float by performing into to float. So this converted 60 converted to float is stored into T1 instruction. Then T2 performs the multiplication of id 3 and T1. Then T3 performs the addition of id 2 into T2. Then id 1 performs the assignment of T3 to id 1. The final result is available in T3 statement, that is assigned to id 1. id 1 represents position. So position stores the value of initial plus rate into 60.0. This intermediate code representation is given to code optimizer. Code optimizer performs code optimization. So it improves the readability and also it reduces the memory consumption of the intermediate representation. Here the code is optimized like this. Instead of converting the 60 into float, directly it uses 60.0. So the first T1 can be modified like this. So T1 equal to id 3 into 60.0. Then these two, the T3 and id 1 equal to T3, these two statements are combined like this. id 1 is equal to id 2 plus T1. So this is the code, this 3 address code. So this optimized 3 address code is given to code generator. This code generator performs some assembly language generation. So in this code generation phase, memory allocation and register allocation are to be done. So this register R2 and R1, these two registers are used as the storage. So in the first instruction, id3, this id3 is loaded into register R2. So this F denotes we are performing operations on floating point values. So LDF is used to represents load id3 into R2, performs floating point operation. So F, then perform R2 with that perform multiplication of R2 and 60. So 60 is an immediate constant, so it is represented by hash symbol before the 60. So the content of R2 and 60 are multiplied and the result is moved to R2. So the R2 value is replaced with the multiplication of R2 and constant value 60. So this instruction is MULF, so multiplication of floating point values. Then id2 is loaded into R1. Then id2 value is loaded into R1. This is given by LDF. Then these two values R1 and R2, the content of R1 register and R2 register are added to perform this one, id2 plus T1. So the contents are added and the result is moved to R1. This is implemented by the instruction add f. Finally, the content of R1 should be stored into ID1. So this is done by STF, store f. So how this initial instruction position is equal to rate initial plus rate into 60 is converted into assembly level language. So this instruction is processed in all the phases of the compiler. In the last, it produces assembly level code. Similarly, some softwares are generated by using available tools. For compiler construction also, there are several tools existing. We can use those tools to generate the compiler. So these are the some of compiler construction tools. The first tool is scanner generator, it is known as Lex. Then parser generator, this is known as YA. Syntax directed translation tools, those tools are used to construct the compiler. Code generator tools, these tools are used to generate the code generator phase of the compiler. Thank you.